Hello, so we're still in motor components and this is video 2 and we would like to talk about motor bearings. Most of the motors in the field we are not allowed, we cannot do the bearing change. The bearing usually is pressed onto the motor, but you can always check. But from what I've seen so far, most of those bearings are not to be changed. But there are two major types of motor bearings: the sleeve bearing and the ball bearing and sleeve bearing. In a nutshell, ball bearings are not used in hermetic compressors because they have the possibility of creating a spark because of the friction. So mostly we rely on sleeve bearing. We'll look at that a little bit. So ball bearings, they have a group of spherical metallic balls that are in two enclosures, and usually they are mechanically pressed, so we cannot open them. But over time, if they get overheated, they go out of structure and they go bad, and you can tell usually by the noise they make or if the motor is overheating. Probably you have faced some of those problems with your car, for example. If your car makes a lot of loud noise from the wheels, could be the bearing, and usually if you touch the rim you will find it a little bit hot. Some of them are permanently lubricated. They have a seal, and that seal has already some grease in it, and once the seal is broken and the grease comes out, the bearing goes bad. And there is some kind of packed lubrication as well, where you have to disassemble the bearing to lubricate it. Some of them are grease fitting. They get re-lubricated every 2 years or every season, and in doing so there are some few drops you can put in a small compartment every year or so, and I've seen few of those actually for inducer fan motors. Okay, so this is what the construction of ball bearing, and this is after it gets sealed. So it's completely packed and sealed, and you can see the spares inside with the spares in between them. And this is a small ball bearing as well. If it goes bad, sometimes it has to be press fit outside or inside the enclosure or the stator. Sleeve bearings are much more like two shafts into each other with soft material. They're also called journal bearings. They're made out of soft metals like brass or bronze, and they're exposed to more higher friction, especially at the startup, because the rotor is resting on the sleeve. There are two types of lubrication: either the oil wick, where you have a reservoir of oil and it will go through osmosis and some fabric into the casing and provide complete continuous lubrication. So this is what it looks like. Anyway, we have our shaft. This is my shaft, and this is my bearing over here, which is it's a connection between two metals, and we have a small little reservoir where we fill with oil, and this oil goes all around, and over time it gets spent, and it has to be refilled every. This is a yarn one, which again has a lot of fabric inside, or some kind of like fibers, and this fiber will lubricate the oil, will provide the shaft with some oil, and the oil will go through those crevices, and again it has to be refilled every season. Not very frequently, but you will need to supply some kind of oil when it dries out, especially if you can notice the noise if you listen to it. This is how it looks like with filter. Moving on to motor drives. Again, we have either direct drive and a motor drive. With a direct drive, the motor have the same revolution as the equipment. So if you have a motor here connected to a pump, motor, obviously it will have the same RPM. But if we have a motor with a pulley and a big drive connected to something else, we'll have different revolution, because the size of the pulley makes a difference when it comes to the RPM. It's kind of like the same thing as your transmission in your car. So your RPM will be at 2000, but your transmission may be going much faster or much slower than that and giving you different torque. So this is what it looks like. Usually it's done for pump. This is an example of direct drive with coupling. different kind of coupling. Some of them are plastic, some of them are actually with a differential, but this is direct drive where we have the same RPM, same RPM. This is a pulley drive, and it's kind of a bifold. Why do we use that? The first reason is to put the motor outside for service, so we don't have to put it inside the compartment and make reaching the motor is more difficult. So, and the other advantage also is we can have different revolutions. So you can tell here the pulley is different size than the motor, which means it turns at different RPMs. And there's a small formula that you can use to determine this RPM. The belt, again, it has to be set at certain tension using a tensioner, but as a general rule, if you turn off the motor and you press on the belt, it should not extend more than half an inch. So we want a revolution of 150. The motor is 350, and the motor and the equipment diameter, that's what I'm going to solve for, and diameter of the motor is 3 inches. So I will multiply 350 times 3 and divide by 150. So that will be 350 times 3 over 150, and I'll get a diameter of 7 inches. How do you check a capacitor? This is extra information just in case, because we want to check the bearing, the belt, the capacitor, and the winding. So we can either use a capacitor tester or use a multimeter to measure the microfarad. And when you don't have that ability, or you don't have that information to know what is the capacitor replacement, you can use this formula. So the microfarad equal this number times the amperage drawn by the capacitor over the voltage. So you have an empty capacitor, make sure it's discharged, you apply voltage to it, be it 120 volts, and you measure the amperage draw. You put a clamp on meter on one of the legs and leave it for 20 seconds, see what is the amperage draw. You multiply that by this number, divide by the voltage, you will get the microfarad. It's a very general rule. It's better to go with the label. So 30 microfarad will be better to find, but if you have to, this is one way to look at it. For replacement, sometimes it's very difficult to find the exact replacement. So if you have a capacitor that is for starting capacitor, you can go with up to equal or up to 20% higher than the capacitor strength, within 20% for a start capacitor. For running capacitor, you can go plus or minus 10%. So if you cannot find the exact one, you should be okay within 10%. Motor speed, we went through that last week. To calculate the motor speed, if it's not possible, you multiply the hertz, which is 60, times the voltage, 120, and you divide by the number of poles, which should be on the motor. If not, you can open it up and count the number of poles if possible. So we have either 2, 3, 4, or 6. So if you have 60 hertz and 120 volts, 2 poles, you're gonna end up with 3,600 RPM. Okay, so just to review the terminology and the material we covered in this section, back electromotive forces are the electromotive forces that is generated by the winding as it pulls current. Ball bearing is provided to support the shaft and give it smoother operation. Bearing is whatever holds the shaft and give it again smoother operation. Current or magnetic relay are devices that cut off the startup winding once we reach a certain RPM. Direct drive is when we have the motor connected directly to the equipment. Full load amperage is the amperage that the motor will draw once it's operative and connected to the load that it is operating. Locked rotor amperage is the startup amperage, and usually it is higher than the regular running amperage. Potential relay This is also a relay that will cut off the startup winding, but it's made out of different material, and it uses resistance. Sleeve bearing, also known as journal bearing, which is two tubes inside each other with a bearing between them or soft material. Solid state relay is the one that also uses resistance, and start relay is same thing as potential relay and magnetic relay. V-belt is the belt connecting the motor pulley and the small roller pulley. It's called a V-belt because it does look like a V in a way.